Hello, my name is Daniel McDonald.
Leonardo.
Welcome to our project, Fractal. Oh shucks, where is Michael? Hey Michael, what are you doing?
Hey man, I'm just checking out these snowflakes with a microscope.
That's so cool, the repeating patterns.
Part 1. What is a fractal? Fractals are a repeating pattern that are also known as iterations. They are self-similar in various different scales. Within fractals, there is a set of numbers known as the Mandelbrot set, which is a set of C values that have a certain iteration outcome for a seed of 0. Fractal geometry is the subject that we will focus most heavily on. Fractal geometry is geometric shapes that tend to have non-integer dimension. They were discovered by Benoit Mandelbrot in 1975. Mandelbrot sought to understand complex patterns observed in nature through mathematics, thus discovering fractals. In addition, he connected art to mathematics in order to discover and explore fractals. Fractals can be found throughout nature in many different types of organisms and in our environment. For example, ferns are one well-known fractal in nature. Another example is snowflakes.
Snowflakes are a great representation of fractals in nature. Analyzing snowflakes in nature is a perfect way to study fractals. These fractals have some special properties, such as they are self-similar, and because of the way they form, no two snowflakes are identical. Snowflakes are actually 6 ice crystals growing off a central crystal. The snowflake's arms are identical because they encounter same atmospheric conditions when forming. Many different types of ice crystals form in the atmosphere, including needles, plates, solid prisms, and hollow columns. The classic snowflakes that we think of are dendrites. These are ones with tree branches like arms. Charts, such as the one above, give us a rough idea of the impact that temperature and saturation have on snowflake shape. We can also see snowflakes outside in the snow where we have an abundant resource in the winter of Massachusetts. This graph shows the temperature points and what type of snowflake will be made. We believe that studying snowflakes will help people better understand nature through a lens of mathematics. Snowflakes are tiny, but at the same time, they have many iterations or patterns to make them infinitely different from each other. This idea can also be seen in fingerprints, where every person has fingerprints and every person has different fingerprints as well. This is similar to snowflakes because there are many patterns or iterations to make the snowflakes or fingerprints different from other snowflakes or fingerprints. Learning about fractals and iteration has helped us see the world in a way we couldn't before. For example, when we see snow falling from the sky now, what do we see? Do we see fractals or do we just see snow? Overall, this project has helped us better understand what a fractal is and how it is shown in nature.
How snowflakes form and how they are fractals. Snowflakes form when a water droplet freezes onto a piece of pollen or dust high in the atmosphere and forms an ice crystal. More water then freezes onto the original crystal and forms to a 6-sided snowflake. They are fractals because snowflake consists of repeating hexagons which grow out of each other. The bands in a snowflake are hexagons, and each smaller stemming from a larger one is similar to the larger one. This forms a repeating pattern. The same shape is repeated over and over again, and this is why it's a fractal. Making snowflakes using Python. We made a simulation that creates snowflakes. The simulation works by the user inputting a temperature where dendrites can form and a saturation, and then it generates a snowflake for the unique snowflakes that will exist in those conditions. Our simulation can be used to see what snowflakes would look like in certain conditions. Our code in action. First, we ran our code, and it prompts us with the type of saturation level for each snowflake. And by this time, you choose a temperature range where dendrites can form, as we're simulating dendrites. Then you put in the saturation level, which I put in 0.25, and you run the code, and it generated a snowflake for us that would exist in that temperature and saturation. And this is it. Here are our FAQs. Feel free to pause the video here if you'd like to read through them. And here are our sources. Feel free to pause the video again if you'd like to read these sources and or copy down the URLs.